Okay, everyone, today we're going to talk about two different types of probability. We're going to talk about mutually exclusive versus inclusive. So we're going to start off with this first slide. And as it says here, when two events share no outcome, we say that they are mutually exclusive. So mutually exclusive means two events that cannot happen at the same time. So for example, if you have a deck of cards and you draw one card out, and we want to know the probability of a jack or an ace. Well, there's four jacks, so the probability of a jack then would be 4 out of 52. Plus, there's four aces, which would also be 4 out of 52, for a total probability of 8 out of 52. So these are an example of mutually exclusive events because there is no card that is both a jack and an ace. It's either one or the other. All right, so if we move over to the next slide, when two events share outcomes, we say that they are mutually inclusive. So this would be where you have something that can occur at the same time. So an example of this would be, again, from a deck of cards. If you're drawing a jack or a heart, well, if you think about it this way, there are four jacks, so 4 out of 52, plus there's 13 hearts, so 13 out of 52. But the difference is this time there is one card that is the Jack of Hearts. And the Jack of Hearts got counted here in the Jacks, and it also got counted here. So in other words, the Jack of Hearts got counted twice. So we need to subtract the Jack of Hearts. We need to subtract that one card that got counted twice. So that adds up then to 4 plus 13. 17 minus 1 is 16 out of 52. 16 out of 52. And that's an example of an event that is mutually inclusive. Okay, so I'm going to slide over to the next screen. So the first thing you have to do when you're trying to answer these sorts of questions is to figure out whether or not you're dealing with an exclusive or an inclusive event. So when you're thinking about a number cube that's landing on a 1 or a 5, so a number cube is just a dice. Think of it as a dice. It lands on either a 1 or a 5. Well, it can either land on a 1 or it can land on a 5. It can't land on both. So we would say that this is mutually exclusive. Selecting a diamond or a black card. Well, diamonds are red and black cards, of course, are black. And you can't have a card that's both a diamond and black, so that would also be exclusive. A number cube landing on an even number or a 4. So an even number, even numbers would be on a dice, would be 2, 4, and 6, or a 4. Notice that in this case, you can have something that's in both. It can be in the even number, and it can also be a 4, and it can also be a 4. So this is an example of inclusive. And finally, a person who plays football and baseball. Well, you can certainly have a person who plays both. They play both football and they play baseball, so that would be an example of an inclusive event. So just keep in the back of your head when you're thinking about these, inclusive means they can happen at the same time, and exclusive means they cannot. So if we scroll over here to the next one, let's do some practice problems. So imagine that we have ping pong balls that have been placed in a bag and they're numbered 1 through 10. So we can make our sample space 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. An even or a 5. So an even would be 2, 4, 6, 8, and 10, and then a would be a 5. So we can simply add those together. So evens would be 5 out of 10, plus 5s would be 1 out of 10. These are exclusive, they can't happen at the same time. So 6 out of 10 would be your answer. All right, let me erase that. Okay, so now let's go back and what about even or a factor of 6? So first let's do the even numbers. Even, 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 or a factor of 6. 6 is a factor of 6. So notice that these are inclusive. You can have something that's both. The even numbers are 5 out of 10, plus the factor of 6, there's one of those, 1 out of 10, But notice that this 6 here happened twice. It got counted twice, so we have to subtract it. So that winds up being 5 out of 10. All right, I can erase that. Okay, so if we move on to the next one, a 4 or a 7. So a 4 would be a 4 or a 7. Notice those are exclusive. So this would be 1 out of 10. So 2 out of 10. Odd or a number greater than 4. So odd numbers would be 1, let me erase that, 3, 5, 7, 9. So there's 1, 2, 3, 4, 5 of those, 5/10. Plus a number greater than 4. So number greater than 4 would be 5, 6, 7, 8, 9, 10. So there's 6 of those, so 6/10. But then we have to subtract these duplicates. Notice that 5 got counted twice, 7 got counted twice, and 9 got counted twice. So we have to subtract 3. So that adds up to 11 minus 3 is 8. All right, so if I erase all those, now we have a number less than 4. So a number less than 4 would be 1, 2, and 3. So that would be 3 out of 10. Plus a number greater than 9 would be 10. So that's 1 out of 10. There's no overlap, so that means these are exclusive. So we can add those together and we get. So the trick for these is if they're exclusive, then you just add them up and that's your answer. But if they're inclusive, you have to subtract the overlap. First, it says find the probability that they are female. So we're going to add up the table. So if I add up the table, I get 19, I get 23, and 18, 24 males for a total of 47 people. Forward. Males would be 24 out of 47. Lacrosse players. Let's add up the players. We have 16 soccer, 20 lacrosse, 11 basketball. So then that's for lacrosse players. Female or lacrosse players. So let's think about circling these. If we circle female players, there's a female player, there's a female player, there's a female player, or they can play lacrosse, which means it could be this one or this one. So we need to add up all those ones that or it could be that. So we need to add up all those females and those lacrosse players that I just circled. So if we add all those up, we're going to get 10 plus 9 is 19, 23 plus 11 is 34 out of 47. All right. So now we'll do the same thing. Okay, so now we're going to do the same thing with the male or basketball players. So if I'm not waiting for Bradley, everybody done? Everybody done? Make a noise. So now for male or basketball players, we can go through and we can select all the male players. So there's 6, 11, and 7, or they can play basketball. So that would be these 7 and these 4. And then we can add all those together and you get 11 plus 11 is 22 plus, right? So for female and soccer, now there's a difference between an or problem and an and problem. An or problem means there's more than one category. As you can see, there's more than one category that we have to add together. An and means we're trying to select the people who are both female and play soccer. Well, this group right here, they're the only ones that are both female players and soccer players both. So then this one would simply be 10. Lacrosse and soccer would be, well, we need all the lacrosse players. So that would be these people play lacrosse, these people play lacrosse, and soccer players, these people play soccer. Wait, there's nobody that plays both soccer and lacrosse players and these female players and lacrosse, which would be these lacrosse players and these lacrosse players. So everyone that I just put a star next to would be female and lacrosse means they have to female and lacrosse means they have to play both. They have to be both a female and play lacrosse. So that would be this group right here. They're the only ones who are both of them. So then that would be 9. Okay, so what I'd like for you to do next is go ahead and do the mutual events practice. Okay, what I'd like for you to do next is go ahead and do the mutual events practice problems and see what you can do with those. I do have the answer keys down at the bottom so that you can go through and you can check your answers. If you have any questions, you can email me or come to the office hours. And then once you feel confident, go ahead and do the homework probability practice. Good luck. I'll see you in office hours.